through a couple of quick examples of condensing logarithmic expressions. We need to know how to do this a lot of the time because when we solve equations, sometimes we have to condense them to get rid of the log. So looking at these, reviewing very quickly the properties of expansion and condensing, we say the first one is this: if we had like log base, say a of a, oh, sorry, not use a, it would be redundant. We say u times v. The same thing as log base a of u plus the log base a of v. Whereas if we had a quotient, we say log base a of u over v. This would be a difference. Okay, we say log base a of the thing on top, u, minus the log base a of the thing on the bottom, v. And then our property of powers, which is log base a of, say, u to some power n. You can actually take that power and stash it out front, and we just get this. We say n log base a of u. So using these properties, what we're going to do is we're going to take these expressions that are written out this way in this video, and we are going to rewrite them back in a condensed form. Okay. So looking at this first one here, you'll notice that I have this 2 indicated. We are going to do this in a certain order, but unlike in our last video where we looked for quotients, powers, and quotients, products, powers, we're going to look for powers first, and then we're going to look for products in the middle again. And then we say lastly we'll look for quotients, anything that we would consider to be a quotient going backwards. Okay, so looking at this up here, you notice that I do indicate this too. What I recognize is this is like ln of some u here, and this is ln of some v. They are in a difference, but this one here has some n out front. And so what we could do is we could put this back up here. And we say what we end up with is this really ln of this thing right here to the second power minus ln of this thing, to the first power. And I notice that these have the same basis also. We say these are both base e technically. And they are in a quotient with one another, or at least I say a quotient because when I look over here I say it's a subtraction issue here. Going backwards, we could rewrite this as the log, so ln of a single quotient, where in this case we say this is like our u and this is like our v. So we say going up here on top we say this is our x plus 2 squared, and then on the bottom we have some x, and we could say, well, then this is condensed as I can get it. Nothing simplifies in here. Also, this is all one logarithm now. We can say that's how I know I'm done condensing. Okay, so again, let's try this again over here. I'll start on the inside. I don't notice any powers other than 1 on the inside. Okay, so when I say inside these brackets, kind of order of operations e. But I notice here that they are in a sum with one another. I'm actually going to take care of this kind of last. You can take care of it first also, by the way. You can distribute it and see that you obtain the same results. But putting these back together first, I notice these are in a sum with one another. So this would indicate that they were originally in a condensed form in a product with one another. So this is like our u. Here is like our v. So in this case we get this, we say 1/3. We're still all in brackets, okay? We say log, and it's log base 2. But we say in a product we had x, let me get that out of here, x times x plus 1. Okay, so we get this right here. Now we can take this 1/3 and put it back up here. So we say this is log base 2 of x times x plus 1 to the 1/3. Okay, so I can build on this. I like to leave this factored. You can actually distribute it if you want through. Factored expressions are good, but the last thing I want to kind of comment upon here is that we have this entire quantity that is to a fractional power, a rational power, which means we could write this as a root, and we are saying all of this was being taken to the first power, so first power, and it is the 3rd root, so it's a cube root of this. So we say the log of the cube root of x times x plus 1 is what we are after.